Pause the video and copy down this board. These are the rules for significant figures. Before I can show you the new stuff, we need to review the old stuff. Back in August, some of you weren't very good at significant figures, so you've got to get good now. Ask questions if you have questions as we go through this. Right along with me. Let's check it out. The first rule of sig figs that you already wrote down, so look at rule 1, states that all non-zeros are significant. Now remember, in sig figs, we're looking at digits that we're sure of, digits that we can measure in a lab, that we have certainty of. So following that rule, if I look at an expression like 57, how many sig figs are there? 2. Non-zero, non-zero, 2 sig figs. All right, what about this one? 888. How many sig figs? 3. Non-zero, 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 3 sig figs. Rule 1 is pretty easy. Rule 2 says that sandwiched zeros are significant. Sandwiched zeros refer to any zeros that fall in the middle of a number, simply zeros that don't start or end the number. So if we have this expression, how many sig figs are there? 3. Non-zero, non-zero, sandwiched 0, 3 sig figs. All right, what about this larger number? 707,007. How many sig figs? 6. Non-zero, 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 sandwich, sandwich, sandwich. All right, so far, everything is significant. Josias, these zeros are all considered sandwiched because they're in the middle of the number. They're stuck between non-zeros. Well, they're sandwiched throughout the entire number. In other words, the zeros are not at the end or the beginning. Y'all are usually pretty good at the first 2 rules. Rule 3 deals with zeros at the end of a number. If we look at an expression like this, you'll see that there are 3 zeros at the end of 5,000. Now, this rule will apply to whether there's 1 0 or a trail of zeros going at the end of a number. The rule states that the zeros at the end of the number will come as a package. They are either all significant or all not significant. The way you know is if you can see a decimal or not. If there's a visible decimal, then the whole package is significant. If there's not, then they're all not significant. Based off that, how many sig figs are there now? There's only 1, just the 5. There's no decimal, so all of those zeros are non-significant. Looking again, though, watch. How many sig figs are there now? Now there's 4. As soon as you can see a decimal, the whole package becomes significant, and now there's 4 sig figs. Watch again. How many sig figs are there now? There's still 4. For those of y'all that said 2, you're breaking the package rule. All of those zeros are either all yes or all no. There's no mix and match. If you can see a decimal anywhere, doesn't matter where, anywhere in the number, then all of the zeros that end that number are significant. You do that one, don't talk. How many sig figs?
3.
There's 3. Non-zero, non-zero, sandwich 0. He could be significant. Is there a decimal?
No.
Nope.
So with the decimals, it's like the first 0 and the second 3.
The first 0 and the second 3?
Yeah.
Then there would be 4 sig figs. Now there's a decimal, and then he would be significant. All right, the fourth and final rule deals with zeros that start a number. When zeros start a number, there could be one at the beginning or a whole trail of them at the beginning, but the rule is simple. Zeros that start a number are never significant. Looking at this, for example, there's a whole trail of zeros starting that. How many sig figs are there?
One.
Just one. All right? Zeros that start a number, you're right, also come as a package, but that package says they're never, ever, ever significant. There's one sig fig there. Now, if there was a 0 on the other side of the 1, he would be significant because of that decimal. But that's dealing with zeros that end the number. All of these zeros start the number. Look at another one. In your head, come up with an answer. Apply all 4 rules. How many sig figs do you see? 5. Watch closely around you. Watch how I count. I'm going to go through all the rules. Rule 1 says non-zeros. Sorry. Rule 2 says sandwich zeros. Sandwiched, sandwiched. Rule 3, zeros that end the number, sometimes, hey look, see the decimal? He is significant. Rule 4, zeros that start a number, never significant. 5 sig figs. Because it's still one of the starting numbers. Well, look at this one. All of these zeros were starting this number, and none of them were significant. The only time a decimal affects a 0 is when we're looking at the 0 that's at the very end of the number. These are both at the beginning. Before we apply these sig figs to the new skill, we have to revisit a very old skill from your elementary school. My apologies if you're already really efficient at this, but some of us are not on the same page. Write this down. You're working with me still. We have to know how to round. How to round. If I wanted this expression to only have 2 digits in it, then I would need to keep the 2 most important digits, or the first 2 significant digits. What are the most important digits here? The 1 and the 0, the very first sig figs that you hit reading left to right. So the 1 and the 0, those are the numbers that are most important if I'm only going to keep 2. However, even though I'm getting rid of all these numbers and I'm getting rid of the 5, that first number that you get rid of has influence over the number next to it. If it is a number 0 to 4, then it will do nothing to that number. If it's a number 5 through 9, it will kick that number up 1. So what will this 5 do to that 0? It'll kick it up 1. So it rounds to 11. All right, let's say that we've got this expression and I only want to keep 4 digits, 4 of them. I want to keep the 4 most important ones, which will be the very first ones that we come to that are significant. So I want the 2, the 5, the 0, and the 3. We'll get rid of the other ones, but this 4 that we're getting rid of will have influence over the number next to it. What will that 4 do to the 3? Nothing, because it's going to leave it the same. It falls in that range. What I want to do is merge these 2 ideas, significant figures and rounding. Here's where the new stuff will start. That says 1,567. You write everything I write. What I want is that number to be rounded to 2 significant figures. 2. So we need to pick then the 2 most important numbers in the expression. What are the 2 most important numbers? The 1 and the 5. The very first 2 numbers you come to that are significant. which means the 6 and the 7 are theoretically going to go away. But that 6 can have influence over the 5. What will the 6 do to the 5? It will bump it up 1, right? Now, here's the problem. We've got the 2 sig figs that we want. However, if you had $1,567 in your pocket, and I walked up to you and said, hey, I'm going to round that money to $16, we'd probably have a violent conversation. This doesn't make sense. You can't round that big number down to this small number. But we still only want 2 sig figs. What can we do to make the numbers make sense? Add zeros. If you add those 2 zeros, the numbers make sense, and as long as you don't put a decimal, you still only have 2 sig figs. The actual rule here states that when you're missing digits between the number you rounded to and where the decimal should live, you'll fill it in with zeros. That happens both directions. I'll show you what I mean. I want to round this small number to 1 significant figure, which means we need to pick the 1 most important number in the value. What is that most important number? It's the 3, because the very first the very first significant figure we hit is the 3. So there's my significant figure. Now, as I said a moment ago, we have to fill in zeros to get to where the decimal is. So we're going to keep these other non-significant zeros because it will make the number make sense. This 4 can influence that 3. What will it do to the 3? Nothing. There is 1 significant figure. Keep going. $216,350. I want this to be expressed in 4 significant figures.
It's 22.
What are the 4 most important numbers? 2163. All right, those are the guys that we're going to definitely keep. We're going to get rid of the other 2, but that first number we're getting rid of can influence the 3. What will it do to the 3? It will bump it up to a 4. Now, it doesn't make sense for 216,000 to round to 2,000. All right, what do we need to add? Yeah, we need zeros to get us to where that decimal lives, and as long as you don't put a decimal anywhere, you still only have 4 sig figs.
Where's my freaking problems?
Pause the video. They're solving these as practice problems. Taking a look at the first example problem, it wants 2 sig figs. The most important 2 numbers sitting over there are the 4 and the 0. Now, we have to put zeros in to get us back to where the decimal was. There's 2 zeros there to get us there. All right? Now, there's still only those 2 sig figs. Those 2 zeros are not significant. It's all the stuff afterwards that we got rid of, which was just a 9. What will that 9 do to this 0? It'll bump it up. There's the answer to the first one. The second problem wanted 3 significant figures. If I pick the 3 most important numbers, there's a 1, a 6, and an 8. Just like that. The other numbers will go away. However, the 4 that was right here can influence the 8. What will it do to the 8? Nothing. The third problem wants 3 sig figs. The 3 most important numbers there are 8, 6, and a 1. Now, the first number that we're getting rid of is the 8 that lives there. What will the 8 do to the 1? It'll bump it to a 2. All right? Now, again, this number doesn't make sense compared to the original number. We need to add zeros up to the decimal. And now we still only have 3 sig figs in the numbers. Makes sense. The last one wants only 2 sig figs. The two numbers that are important there are the 9 and the 0, because both of those are significant in the original value. We need to add zeros to get back to the decimal, which was just 1 0 there. We still only have 2 sig figs. The first number that we got rid of all those numbers was a 2. What will the 2 do to that 0? Nothing. And that will be your answer. What is 4 times 4?
16.
What if I told you it's 20? What if I was serious and I told you that if on Wednesday's test, if I just give you the number 4 times the number 4 and you put 16 as the answer, then I'll count it wrong? Focus. Look here. You don't want to miss this. Write down this problem. You should have a calculator near you. Grab one from a nearby desk if you don't. And type in the problem that I just put up there. It says 8506 divided by 0.02. The answer my calculator gives me is 425,300. What I'm telling you is that's wrong. And even though that will be, if this was a test question, that would be a choice. And if you pick it, I'll mark it wrong. Because significant figures have very special math rules when being certain of your answer. And here's what the rule states. The answer to a multiplication or division problem can only have a number of significant figures equal to whichever of your starting numbers had the smaller amount. Let me make sense of that for you. If I look back at my 2 starting values, my first expression had 4 sig figs, and my second expression had 1. Do you see where the blue numbers come from? All right. So what the rule is that the answer can only have a number of sig figs equal to the smaller number I just wrote up there. It can only have 1 sig fig. Based on what we just learned, we know that if I'm only going to pick one number, the most important number here is the 4. And none of the others are as important. The 2 could influence the 4, but it won't. And now I need to get to the decimal with zeros. The only correct answer, according to sig figs to this problem, is 400,000. And that's why, if I give you 4 times 4, you would say that there's 1 sig fig, there's 1 sig fig, so this answer can only have 1 sig fig, making 16 impossible. The 1 is good, and the 6 will influence the 1, and then we need to get to the decimal. 4 times 4 is 20. Let's practice. Write this down, work with me, go give a last lecture, come on. In my calculator, 0.222 times 0.7000, I get 0.1554 as my answer. However, that is not an acceptable answer. Let's look at why. Going back to my starting numbers, this expression had 3 sig figs. How many sig figs does that expression have? 4. Remember, zeros that end a number are significant if there's a decimal present. The smaller number wins, so our answer must have 3 sig figs. The 3 most important numbers in this expression are the 1, the 5, and the 5. The 4 will go away. It could influence that 5, but it won't. This one's kind of funky, watch. On my calculator, 23.7 times 3.8, I get 90.06 as an answer. Let's see if that is an acceptable sig fig answer. Here we had 3 sig figs. Here we had 2, which means my answer can only have 2. I'm going to keep then the 9 and the 0 as the 2 significant figures. The first number I'm getting rid of could influence that 0, but 0 will do nothing to 0, so it stays like that. What is the problem? We need the way it's written, there's only 1 sig fig, because that 0 is not significant, and we don't want 1 sig fig. We want 2. Now there's 2 sig figs, because there's a decimal present. The rule to keep in mind, if that just freaks you out, is if your final answer ends in a 0, go back and double check and make sure that everything is lining up and square. They're solving those 4 problems in the blue. Pause and solve. On the first one, 45.76 times 0.25, I get an answer of 11.44. That's what the calculator says. Looking back over my work, I've got 4 sig figs there, 2 sig figs there, so my answer must have 2 sig figs. My most important numbers here is the 1, 1. That 4 could affect that 1, but it won't, so the answer is just 11. The next one is a number divided by 1, which will always be that number, so it's 4278 again. However, 4 sig figs, 3 sig figs, my answer must only have 3 sig figs. The 3 most important are 4, 2, 7, so there's my 3 that I care about. The 8 can affect the 7, and it will. And now I've got an empty spot in between the 8 and the decimal, which is when those zeros show up to make the number make sense. On the next one, I get an answer of 0.8104. I've got 4 sig figs here, 2 sig figs here, so I only want my 2 most important numbers, which will be the 8 and the 1. That 0 could affect that 1, but it will not. We've got 3 things multiplying on the bottom. Your calculator will give you an answer of 6.8. How many sig figs is my answer allowed to have here? Only 1. Look at that number. There's only 1 sig fig there. Without a decimal, it's 2, 1, 2. So my answer can only have 1. I'm going to keep the 6, but the 8 can affect the 6, and it will.